In this video, I will show you how to use the expression for the charge on the capacitor and the current in the inductor. I have written those expressions here. The charge refers to the capacitor, the current refers to the inductor, and the omega, the constant omega, is 1 over the square root of LC. Now, I have written here some numbers I'm going to use for the inductance, 50 Henry, and for the capacitance, 2 farads. And let's go ahead and use these two to find omega. And the product of LC is just 100. The square root of 100 is 10, so I got an omega of 0.1. The units are seconds to the -1. And now I also need to know what is the charge Q naught that I start with on the capacitor, and let's make that to be 0.5 coulombs, which is a large charge. It is a lot of charge. Now, okay, one thing that I will mention, so this phi naught refers to the refers to the initial phase. To raise this, so this phi naught is the initial phase. What does that mean? So if phi naught is 0, then the charge is simply is really a cosine function. If phi naught is 0, the current is really a sine function. Now, if you add another number here for the initial phase phi naught, what we're really doing, you're shifting the cosine left or right, depending on whether this is positive or a negative number. But the charge will remain to be a cosine function, and the current will remain to be a sine function. What this initial phase does is simply moving your cosine graph to the left or to the right, and the sine graph to the left or to the right. But it doesn't affect the shape of the graph. The shape remains the same. So the charge and the current oscillate in the same way. Now, to make my life easier and to illustrate the calculations, I will just use for the initial phase 0. Okay, if you want to do something slightly different, just use a different number. At the end of the day, as I said, the shape of the two graphs remains the same. It doesn't change anything qualitatively. Now, the way that I will use this, so Q as a function of time will be Q naught, so it will be 0.5 times the cosine of omega t. I found omega to be 0.1, and as I said, the initial phase I'm going to use 0. For the current as a function of time, it will be minus omega, which is 0.1, times Q naught, which is 0.5, and then it will be the sine of omega t plus 0. Now, the current then will be minus 0.05 times the sine of 0.1 t, and then this is the expression for the charge, this is the expression for the current. Let's see what happens when t equals 0. So at t equals 0, the 0.1 times 0 will give me 0. The cosine of 0 is 1, so the charge ends up being exactly 0.5 coulombs. And the current at t equals 0, if I plug in the 0 for time, 0.1 times 0 will give me 0. The sine of 0 is 0. and doesn't matter what I have here, the current will be exactly 0 amperes at t equals 0. Now, you can do this with any other value for time you want. So long as you plug in the number for time, you will find the charge and you will have the current that's flowing in the circuit at that moment in time, and that's the way that we use these two expressions.